Okay, as we continue on to topic 8.3, we're going to study quadratic equations in a little more detail here and pick out some interesting things about it. As we look at the quadratic formula that I have left up here from the previous lesson, we see something under the radical sign here. This radicand under the radical sign has a special place in the quadratic equation. It is called the discriminant. And what it does, just by looking at the discriminant, it will determine the kinds of answers you're going to get. For instance, if the discriminant is greater than 0, that is, this unit in here is greater than 0, you're going to have plus or minus 2 answers that are going to be real, and it could be rational. If there's something left under the radical sign here, if nothing is left under the radical sign, they would be rational. And if something is left under the radical sign, like the square root of 2 or something, then it could be irrational. But they are 2 real solutions. Now, if your discriminant, the radicand here, equals 0, then it's going to be plus or minus 0. You're only going to get one answer out of this, because you're not going to have 2 choices. This is 0, so it's just negative b over 2a. That is your answer. You get one answer if your discriminant equals 0. Now, how about if your discriminant is less than 0? That is, you have a negative under the radical sign. Well, then these are imaginary numbers. You're going to get 2 imaginary solutions. So that's sort of the background for this section. And they're wondering, well, how do you determine the number and kinds of solutions you're going to get from a quadratic equation? Well, the answer is you look at the discriminant. And keep in mind, the discriminant has A, B, and C under it, or in it. So what you have to do, again, is be sure something is in standard form, so you recognize what's A. Well, here A is 1, B is a negative 3, and C is 10. Now this is interesting here because there is no B term here. Okay? So A will equal 1. There is no B term, so B equals 0. And C equals a negative 12. And similar here. A is 1, B is going to be 0, and C is 15. Now here we have an A of 6, a B of negative 5, but C is a 0. And here we have A is 6, B is 19, C is 10, and A, B, C. All right, so what I'll do is I'll keep this short. I'm going to write the discriminant for each of these, and then let's see what we get. Okay, so what I did is I took my A, B, and C, put it into the discriminant. There's my B squared minus 4A times C. When I did this, I get a negative 31. Now, recall that that's going to be under a radical sign. So these are going to give me two imaginary numbers because my discriminant is less than 0. When I plugged it here, I got a positive 48. This is not a perfect square, so I'm going to get two real solutions that are going to be irrational. Here, when I plug this into the discriminant, I get a negative 60. Again, when I take the square root of that, that's going to be an imaginary number. So our discriminant is a negative number, less than 0. It's going to be two imaginary solutions. Now when I do number 8, again, taking my A, B, and C, putting it into the formula, I get my discriminant is 25. The square root of 25 is 5. Remember, that's the plus or minus. So here I'm going to get two real solutions, but they're going to be rational. I could actually factor that. Well, that's okay. But I get from my discriminant two rational, real solutions. I'm being redundant there. For number 9, again, here's my discriminant. It comes out a positive 121, which is a perfect square. So I'm going to get two real solutions that are rational. And for number 13, just to give you a little bit of something, when I put that into the discriminant, the sum of my discriminant is 0. So up here, this is 0. So I'm only going to get one real solution. Okay, so there's lots of stuff. I wanted to explain what the discriminant is and how it's used to predict kinds of answers you're going to get when you're doing the quadratic equation. And now it's your part to go out there, do the practice and the quiz bees. All right, in this next part, they're asking us to write a quadratic equation having these answers. And again, we're studying quadratic equations. Here are the answers. What would the equation have been? Well, back in chapter 5, we spent time in which we had factors equal to 0. And these factors would have been a 5 and a 6. And this would be like an x there. And what would the signs of those inside? Well, opposite signs. So the 5 would have been positive. The 6 would have been negative. And that would be the factorization. But we want an equation. So we need to FOIL this now. X squared. This is going to be a minus 30 out there. And my middle term is going to be a negative x. And that's the equation that when it was factored, each of the factors equal to 0 gave us these as our answers. Okay. Now this next one, it says only 4 is the solution. So you might be thinking, what's going on here? Well, it's going to be x. Remember, Remember, there's quadratic equations, so we need 2. If we had something like that, equals 0, and what would the equation have been? Well, the original equation is this squared, which will be x squared minus 8x plus 16 equals 0. So this is a perfect square trinomial that factored into a binomial squared, that when it's equal to 0, we only get a positive 4. Even though it's the only solution, there were 2 of them. Again, this is to the second degree. So this is what they're expecting you to kind of come up with as we study quadratic equations. Okay, as we continue, let's see if we can figure out a pattern here based on what we just did. Here are the answers. So we know we're going to have 2 sets of parentheses. We're going to put the opposite signs there. And then there's our factors that we're going to FOIL into our equation. So this one's pretty easy. This one's a little tricky. Again, we're going to put parentheses, x minus 4, and here it's x plus 5/3, but in order to get the 5/3, we put the 5, which is the denominator, by the x plus 3, and that's our factoring of this, and we're just working backwards to things we did in the past. FOIL this, and we get that. Okay, so all of these are things that we've done. We went this way, that. Now they're asking us to go the other way, because what's happening here is sort of interesting. Here the answers are a negative square root of 5, a positive square root of 5. So again, we're putting in our parentheses. X plus the square root of 5, x minus the square root of 5. These are actually conjugates. And if we FOIL these conjugates, we get a difference of perfect squares, sort of. Now normally you wouldn't be able to factor that. But we're getting ready for some higher level math things where we can actually factor that now, where we're going to use radicals. And this one the same way, x minus this, x plus this, and these are conjugates, so there's no middle term. We square our first, get x squared, and now we're going to multiply this times this. Well, this will give us a negative 9 square root of 100. Square root of 100 is 10. So negative 9 times 10 is a negative 90. Okay, we don't want to make this tape too long. So there are some of the things. The discriminant, and now working backwards.